Good morning, dear students. From today, we will proceed to the second unit of our syllabus, that is statistical classification problems. And we will try to understand what is statistical uh, classification problem. Actually, the problem of statistical classification arises when an investigator makes a dozen measurements on an individual and wishes to classify the individual into one of several categories on the basis of those measurements. The investigator can not directly identify the category to which the individual belongs, but used measurements to get the appropriate group from which the individual belongs. In many cases, it can be assumed that there are a finite number of groups or populations or categories from which the individual might have come, and each group is characterized by a probability distribution of the measurements. Thus, an individual may be considered as a random observation taken from a group. So, this line might have come, and each group is characterized by a probability distribution. So, a group here is characterized by a probability distribution of the measurements. So, this is what we call a statistical population. Actually, a statistical population is characterized by a probability distribution. That is why you have seen the normal population, the binomial population, the Poisson population, and the similar things like that. So, any standard probability distribution will be identified in order to understand a statistical population. So, whenever we talk of a population, it is not a general population that what we see in demography, but this is the statistical population, which is always associated with a particular probability distribution. So, do not confuse whenever we talk of a population and a statistical population. So, if we understand from the context it is a statistical population, the term statistical will be omitted. It will not be used repeatedly. We will simply talk of a population, and you understand that that is a statistical population. Okay, this is the statistical classification problem. We understand we have an individual and we have a K population. The individual belongs to one of the K populations, suppose, but we do not know, we do not directly identify, we cannot directly identify the population to which the individual belongs. But we have a series of measurements, a dozens measurements on that particular individual, and on the basis of those measurements we will try to classify statistically the population to which the individual belongs. So finally the problem is thus given: an individual with certain measurements, we try to identify the population from which it comes. For example, let us see this example. This is very interesting example. Prospective students applying for admission into college are given a series of tests, what we call admission tests. A series of tests. This is in the admission test, and the vector of scores, the marks obtained, this is the marks obtained in the test, is noted for each candidate, is denoted by X bar. We have two populations here, namely the population of students who will complete the college course successfully, and number two, the population of students who will not complete the college course successfully. So those who will not. The problem is to classify a student applying for admission into one of the two populations on the basis of the scores obtained in the admission test. A very simple example, but in the beginning it is a very illustrative of what actually a statistical classification problem is. So we have a group of candidates, and we have to identify each one of the candidates into one of these two populations, and one population consists of those students who will successfully pass the college course, and the other population is the complement of the population, that is those students who will not complete the college course successfully. So on the basis of those admission tests, we will allow them whether to admit or not, because the one who belongs to the first category, the population who will complete the college course successfully, will be admitted, and those who belongs to the other population, that is the population which consists of those students who will not complete the college course successfully, will not be admitted. That is the idea. So in one sense, the problem of statistical classification is to identify the membership of a given individual A to one of several well-known, this should be well-known and well-defined populations, say P1, P2, Pk, from one of which the individual might have come. The classification is to be done on the basis of the measurements on the various relevant characteristics, is to be noted, of the individual. Okay, so the individual A, we know that it belongs to one of the K populations, P1, P2, Pk, but which population it really belongs is to be done on the basis of relevant characteristics on A. That is the problem of statistical classification. So the problem of statistical classification can be viewed as the problem of classical hypothesis testing problem. In that, what is our hypothesis? Our hypothesis is not A belongs to Pi. I goes from 1 to K. That means I may be P1, P2 or Pk, where one and only one of the K alternative is to be accepted. In this case, we have K hypothesis. Okay, we have in altogether K hypothesis. A belongs to P1, A belongs to P2, and so on. A belongs to Pk. So in the case of our classical testing problem, we have only two hypotheses, that is the null hypothesis and the alternative hypothesis. Here we have K hypothesis. Okay, so the difference is that the problem of classification is a generalization of the classical testing problem, and when K is equal to 2, it becomes exactly the classical testing problem, where either A belongs to P1 or A belongs to P2. Then in that case, it is the classical testing problem. Otherwise, we have a K populations, and in that, it is a statistical classification problem. We have some differences between classical testing problem and a classification problem. In the classical testing problem, the alternative hypotheses are not well defined. In classification problem, all the hypotheses are well defined. So alternative hypotheses are not well defined in the case of our classical testing problem. As for example, theta is equal to theta naught against theta not equal to theta naught. So theta not equal to theta naught is a very crude statement. It is not specified. Theta not equal to theta naught is very crude because we do not assign any value of theta. But in the case of null hypothesis, theta is equal to theta naught. If it is accepted, then it is good. But if it is not accepted and the alternative hypothesis is accepted, that is theta not equal to theta naught, it is not well defined. Theta not equal to theta naught does not make sense in any way. Okay, but in the classification problem, all the hypotheses are well defined, because you see in the classification problem, individual A belongs to Pi, and all Pi's, P1, P2, Pk's are well defined. Secondly, in classical testing problem, more attention is given to the null hypothesis, and virtually the alternative hypothesis is not given much attention, because the whole procedure consists in maximizing the probability of rejecting a false hypothesis, a false null hypothesis. This is 1 minus alpha, you know. Alpha is the probability of rejecting when it is true. So here it is probability of rejecting a false null hypothesis. So in this case, we give our due attention to the null hypothesis, and the alternative hypothesis is not given our much attention as we give to the null hypothesis. Okay. So on the other hand, in classification problem, all the hypotheses are equally treated. So they are given equal weights in the case of statistical classification problem. That is the second difference between classical testing and a classification problem. Number 3, prior information is of no value in classification problem, whereas testing of hypothesis uses prior information. You know prior information, prior probability. We use, you have seen in the case of decision theory, chapters, you have seen that we use the prior information in the testing problems and the estimation problem, but in the classification problem we never use the prior information. So this is the third difference between classical testing and a classification problem. So up to this I will do for today, and I will continue this chapter in the next video. So have a good day ahead. Stay safe, stay home.